In this lesson, we're going to look at the special exponential function f of x equals e to the x power. In our last lesson, we looked at graphing basic functions, f of x equals 3 to the x, f of x equals 5 to the x, etc., and how to move them around with transformations to find graphs of new functions. In this lesson, we're going to look at a special graph where my base is the number e. So let's talk about the number e. If I have a number line, and I were to just plot points on my number line, we could mark our integers here, and then we could move into our negative integers, and we could put fractions, rational numbers, and we could put irrational numbers, for instance, say pi, or I guess that's 1.5 there. Hold on. So 1/2 is here. And then we could say 1.41 we know is the square root of 2. We can just keep adding infinitely many numbers on this number line. A new number that we're going to look at is the number e. And e is approximately equal to 2.7182, and because this is an irrational number, it just keeps going on forever and never starts repeating. So approximately equal to 2.7, so if I go out here, I have the number e. And it's important to realize that e is a number. It is not a variable. It's a number just as valid as the number 1 or the number 3 or etc. So it's not going to change values. Later, when we look at our applications of exponential functions, we'll talk more about the number e and where it came from. But for now, it's enough for you to know that it is a number, just like the number 1, just like number 2, but it's approximately equal to 2.7, so we can find it on a number line. So if we're going to graph our function e to the x power, we're going to use that same method that we learned in our previous couple of lessons, where we just make a t-table and we plot 3 different ordered pairs. And then we can graph our exponential function by plotting those 3 points and knowing what the shape of our graph is. If I let x be -1, then e to the -1 power, remember it's 1 over e. If x is 0, that's equal to 1. And if x is 1, e to the first power is just e. E is a number, so we can write 1 over e and just e. And then when we plot those, when we draw our graph, we have 1, 2, 3, and then right here at approximately 2.7, we have e. So we're not going to list it as 2.7. We list it as e, the exact number. And then we can plot our 3 ordered pairs, and we have 0, 1, 1e, and if we go over here to -1, we're going to think 1 over e. That's going to be somewhere between, since e is between 2 and 3, 1 over e is going to be between 1/2 and 1/3. So we just go over here and eyeball a number, and that's going to be 1 over e. And as always, with a basic exponential function, our horizontal asymptote is at y equals 0. So we put that on here. And then we know the shape of our curve is the same shape it always is. And we draw our exponential curve, f of x equals e to the x power. Now that we've graphed our basic function e to the x power, we can do transformations. So for instance, say we have the function g of x equals e to the x plus 4. The method that we've learned to graph transformations of basic exponential functions is to graph the basic graph, which in this case is e to the x power, list our transformation, go back to our basic function, and move each of these 3 ordered pairs according to our transformation. So I want you to pause the graph, or excuse me, pause the video for a minute and work on doing that. Okay, so we see that our basic graph was e to the x power, which we already have graphed here. So we're going to list our transformation. This is plus 4 outside of the function, so it is up 4. And that means that we can move each of these 4 ordered pairs up 4 units, and we can move our horizontal asymptote up 4 units. So our horizontal asymptote was y equals 0. It moves up to y equals 4. And then we take each of these 3 ordered pairs and move them up 4 units. Let's start with 0, 1. If I move it up 4 units, it's here at 0, 5. If I take my point 1e and I move it up 4 units, I'm going to have 1, and then we're not going to do an estimate here. We're going to do the exact number. And if I take e and I add 4 units, it's literally just the number e plus 4. So it moves up 4 units. To about right here. And I can check that by saying that I am e units off of my horizontal asymptote. And then I can look at my point here, negative 1, 1 over e. And if I have 1 over e plus 4, that's 4 and 1 over e. So I'll be over here at negative 1. I'll be 1 over e units off of the horizontal asymptote at 4 and 1 over e. And then I have my curve, and I draw my new graph. So this is the graph of g of x equals e to the x plus 4. So even though this looks different because it has an e in it, we can use the exact same methods that we used before if we had 2 to the x or 3 to the x or 5 to the x, etc. And we always want to use the number e for my exact value rather than a decimal approximation.